Project management has a scaling problem. No matter the team size or the stakes, progress is almost always forced through a single, constricted administrative bottleneck. This chart illustrates the daily reality for most project managers. 70% of a manager's schedule is consumed by manual tracking, updating logs, and chasing status reports, leaving only 30% for strategic work. A project management office is designed to optimize resources and clear operational roadblocks, but when its leaders are bogged down in data entry, that strategic purpose is lost to administrative overhead. This systemic failure is the primary driver for a transition toward multi-agent AI architectures, a framework designed to automate the administrative layer by 2026. This shift replaces the single human point of failure with a central hub supported by a network of 7 specialized AI agents, each targeting a specific workflow bottleneck. To see how the system works, we will reverse engineer it layer by layer, tracking the flow of information from raw project data to executive communication. When administrative tasks scale linearly with project volume, shifting from manual execution to an automated systems architecture is the only mathematical way to scale operations without a corresponding increase in headcount. At the base of this architecture is the execution layer. This is the intake point, where unstructured operational data enters the system. The first node operating at this level is an agile processing agent that interfaces directly with backlog management platforms like Jira. This agent automatically translates raw project requirements into structured user stories, assigning acceptance criteria and sprint priorities without manual intervention. Operating alongside it is the second node, a real-time auditory capture agent deployed into team meetings. As the team speaks, this agent identifies definitive decisions and immediately assigns action items to the relevant team members based on the conversational context. If a potential delay is mentioned, the agent logs the risk and routes it into the project log, removing the need for a human to manually flag the issue later. These two agents form a continuous passive data intake pipeline, capturing the raw inputs of daily operations with zero manual entry required. Establishing this autonomous execution layer removes the human effort previously required at the start of the project lifecycle. With the base data secured, the architecture expands into the analytical layer, where information from the execution tier is processed for strategic meaning. The third agent solves the time drain of weekly status compilation. This reporting agent simultaneously queries the data streams from Layer 1 and renders them into executive-ready dashboards in minutes. The fourth agent shifts the focus from reactive risk logs to a predictive model. It analyzes delivery patterns, focusing specifically on team velocity metrics and hidden dependency chains between different departments. By recognizing these patterns, the system flags a delivery anomaly long before a human manager would notice the trend. This analytical tier transforms project management from reporting on historical failures to predicting future outcomes. Traditional linear schedule forecasting often fails in complex environments because humans cannot reliably account for cascading delays. The fifth agent serves as a predictive simulation engine to address this complexity. Using historical project data, this agent runs Monte Carlo simulations against the timeline to calculate the probability of various scheduling outcomes. These simulations provide the data needed for accurate resource allocation and headcount forecasting based on statistical reality. Leveraging computational simulation removes the bias and guesswork that typically compromise project planning. The generative communication layer is the apex of the network, where analytical insights are distributed to the human team. The sixth agent standardizes operational artifacts using the data flowing from the layers below. It autonomously generates project charters, requirement documents, and release notes, ensuring all formal documentation is current and accurate. The seventh agent addresses the friction of manually updating diverse stakeholder groups. This agent performs contextual translation, taking a single data point and restructuring it for different audiences. For executives, the agent produces high-level business impact metrics. For engineering leads, it routes the same data as granular technical specifications. This ensures informational alignment across the organization without the manager having to draft a single custom update. This 3-layered architecture operates continuously as a single, unified ecosystem. This system functions as an autonomous nervous system for enterprise administration, managing everything from data intake to distribution. These networks do not replace human intuition. Instead, they shield the core mission from administrative noise, allowing the manager to focus on high-value work. This defines a newly isolated human domain: pure leadership, contextual decision-making, and complex negotiation. The division is clear. The AI domain handles deterministic execution and data analysis, while the human domain handles strategy and judgment. A manager orchestrating this 7-agent system operates with a level of efficiency that manual tracking simply cannot replicate. Audit your current workflow and identify which of these 3 layers, intake, analysis, or communication, is your primary operational bottleneck. Subscribe for ongoing strategies in PMO leadership and systems architecture. The future of project management belongs to systems orchestrators, not task administrators.